Okay, last problem that we're going to do here on your homework set 39. This is problem 48 on page 539. You've got problem 37 to do. These are both about baseball diamonds. So, good luck if you don't know anything about baseball. I'll probably show you, if you don't know anything about baseball, I'll probably show you what you need to know right here. So you soccer players out there, listen up. This says Little League Baseball field. According to Little League Baseball officials, the diamond is a square 60 feet on a side. I never realized how stupid that sounds. The diamond is a square. Okay, so here's the Little League Baseball field. It's called the diamond. We got first base, second base, third base. We got home plate. And according to your problem, distance between all these bases is 60, and this is a square, so these are all right triangles. You might think those are the bases. They're not. They're the little indication that those are right triangles, 90 degrees. Okay, it says the pitching rubber is located 46 feet from home plate on a line joining home plate and second base. So there's a line, okay? And let's see, here's 60 feet. I don't quite know where 46 feet is, but there's the pitching rubber, there's the mound. This distance right here is allegedly 46 feet, okay? And so here comes the first question. How far is it from the pitching rubber to first base? Well, let's just kind of draw a line and make a little triangle up. And actually it's this triangle right here. I'm going to get rid of this line. Get rid of both those lines. Okay. That is 46. That is 60. We don't know what that is, but we know what this is because this is bisecting this. This line is bisecting a 90-degree angle. So that's 45 degrees. Okay. So how the heck are we going to do this? I've forgotten the question already. How far is it from the pitcher's mound to first base? Well, look at this. Okay, I'm going to just call that A, and I'm going to say that I know that side, and that included angle, and therefore by the law of cosines, told you there's a lot of legal issues in chapter 8 here. By the law of cosines, A squared is equal to this side squared, 46 squared, plus this side squared, 60 squared, minus 2 times 46 times 60 times the cosine of that angle, 45 degrees. And you know the cosine of 45 degrees, right? It's 1 over root 2. You learned that a long time ago, so long that you've probably forgotten it. So all I have to do is say that A is equal to the square root of all this stuff. 46 squared plus 60 squared minus 2 times 46 times 60. What did we say that was? 1 over root 2. Take the square root of everybody and you've got A. Okay? So I just solved this expression up here for A with cosine 45 equal to 1 over root 2. So let's get the calculator out, and I'm going to square 46, get some huge number. I'm going to square 60, get some huge number, and add it. I'm going to take 60, I'm going to multiply it by 46. I'm going to multiply that by root 2. Right? 2 over root 2 is root 2. I'm going to subtract that from that previous sum, and I'm going to take the square root. And I'm going to get an answer. And the answer is A is equal to 42 point, I'm going to need this thing, maybe 576 here. I'm just going to store this number. It's essentially 42.6 feet. These are all feet. Okay, so there's the first answer. What's the second question? The second question says, how far is it from the pitching rubber to second base? Well, that, I think we should all be embarrassed to be asked that question because I believe we can find this length, can we not? It is the base of this isosceles triangle 60 by 60. I say we can do that. How can we do that? We could do that by the Pythagorean theorem, right? Because this is a right triangle. This is the hypotenuse of that right triangle. So what's the, okay, so the distance home to second is going to be equal to squared. We're going to call it d, and we're going to say that d squared is equal to 60 squared plus 60 squared. This guy squared plus this guy squared is equal to that squared. So d is going to be equal to the square root of 2 times 60 squared, which is equal to 60 root 2, which is equal to 60 root 2 times 84.85. And so if I subtract, so distance pitching rubber to second, that's called a pitching rubber. Pitching rubber to second base, that's second base, because this is first base, and you go there first before you go to second. Don't go this way. A lot of people try to do that. Doesn't work. Don't go that way either. Go that way. So distance, pitching rubber to second is just this, 84.85 minus, what did we say, 46. Okay, so 46, subtract. I've got an answer. 38 let's just say 38.9 feet. Okay, so we're just moving right along here. We've done part A, we've done part B. So the next question. If the picture faces home, through what angle does he need to turn to face first base? I don't have the pitcher faces home, turns to faces first base. Okay, they're asking what this angle is right here. And how the heck are we going to find that? I believe since we've just, I don't know. Do we find this distance? We did. So we know this distance, we know that distance. What's the easiest way to do this? I think the easiest way to do this is using the law of the sines. Okay, we want this angle right here. I'm going to call it, I can't call it A, I'm going to call it C. I'm going to say that the sine of C all over C is equal to sine of C all over 60. It's equal to something we know. That's equal to the sine of 45 all over A, which is equal to the sine of 45, also known as 1 over root 2, all over A, 42.6 feet, is equal to 1 all over 42.6 times root 2. What the heck am I doing? If I multiply, so if I say that the sine of C is equal to 60 all over 42.6 times root 2, I'm going to calculate that. I've got a 2 square root divide. I've got a 42.6 divide. Jiminy's. I see. So the point is that the angle is very close to 90 degrees. So I got 0.9959. I'm going to take the arc sine of that. Yeah, and it says C is 84.8 degrees. Let me look over my shoulder here and see if I've got an answer to that. I've got 85.2. I'm wondering why I have a slightly different answer. It's because I rounded this darn thing up, right? And I didn't keep it. So they give an answer of 85.2 rather than our 84.8. But I've got to tell you, It's because I rounded this, I think. Just a quick comment about these things. If you're trying to chase an answer, in this case, the answer that was given was 85.2. So we're kind of wrong here in this digit. If you want that to be right, you're going to have to keep 2 digits of at least 2 digits of accuracy here and wherever else. So I'm going to live with that. If you want to try to get it right, the book gives the answer as 85.2. I think we're close enough. I think we just have a round off error. That's making things different. That's my story, and I'm sticking with it.